Hello. Please confirm that PPT is visible to you. Hello.
Yes, it is visible.
Okay. Okay. So myself Shubham from ISI India. Today we are going to study about introduction to battery pack architecture, right? So as we all know that the electric vehicle is the most blooming industry, and the most important part inside the electric vehicle is a battery pack. So the battery pack is a source of fuel to the electric vehicle, from which the electrical energy is given to the motor, and in the motor the mechanical electrical energy has been converted into mechanical energy and used to drive the vehicle. So, uh, fuel source. So, what is the fuel source? Fuel source is nothing but whatever energy, it is the chemical energy stored inside that source is been converted into another form, like our petrol or diesel car, right? So that is the source of energy there, petrol or diesel. And in that IC engine, that diesel or petrol is converted into mechanical energy, means the chemical energy which is stored inside that diesel and petrol, it is been converted into mechanical energy. Same like that in electric vehicle, the battery pack is the fuel source. In this battery pack, we are storing electricity, we are storing electrical energy, and that chemical energy has been converted into electrical energy when we connect some wires or terminals to that. So today we are going to see all these things. We are going to see how the electricity is being stored inside the battery pack. What is the electrochemical cell? What is the redox reaction? What all the internal things goes on inside the electric battery pack, right? So especially we are going to talk about the lithium ions. Again, the charging, discharging of cells, battery characterization, battery pack architecture, and what are the battery failure reasons and how can we avoid them, right? So what is the electrochemical cell? A electrochemical cell is an electrochemical unit that converts chemical energy contained within its active material directly into electrical energy by the means of electrochemical oxidation reduction, which is also known as redox reaction. So what is electrochemical cell? It will convert chemical energy which contains some active material, right? What is active material here? Like lithium ions, lithium, or whatever the mixture we are using, like alkaline, lead acid. So this active materials store energy inside them, the chemical energy. That chemical energy is converted directly into the electrical energy. There the reaction happens like oxidation and reduction. The oxidation happens and reduction happens. So the electrons are released and electricity is being generated. We can also store the energy and we can also store the electricity inside them. Yes, am I audible?
Yes, sir, you're audible.
Yes.
Okay. So these types of reaction involve the transfer of electron from one material to another via the electrical circuit. So we are generating electrons here. When the electrochemical reaction happens, when the oxidation and reduction happens, the electrons are loose. So this active materials, they will lose electrons. And after that losing of electrons, what we will do? We will transfer that electrons from one material to another via the electric circuit, like whatever load we are applying there, like let's say the motor or whatever, like DC to DC converter or our charger, or let's say headlamps, lights, indicator, whatsoever. So what we are doing there, we are transferring the electron from the conductor via the electrical circuit. What is the electrical circuit? Nothing but our conductors, which is connected to the load, a closed loop circuit, right? When two or more electrochemical cells are combined together, either in series and parallel, such combination is known as battery. So one cell, when we will combine one or two or more cells with them, they can be combined in series or parallel, so they will form an battery. So single cell is nothing but a single unit, and when we will combine two or more units in series combination or parallel combination, then it will be known as battery. So for your information, when we will connect positive terminal to negative, again the negative terminal to positive, positive terminal to negative, it will be series connection. And when we will connect parallel to parallel, parallel to parallel means what? Positive to positive, positive to positive, and from the round side, lower side, negative to negative, negative to negative. So that will be in parallel combination. So when we will combine the cells in this manner, either in series or parallel, it will form an battery pack. So now we will see some main components of cell. So as you can see in the image, the outermost part is made up of aluminum, which is also known as can. In this can, we are inserting the strips of lithium ion, which is folded in the circular shape. And you can see there are three strips here. First is anode, another is first is positive electrode separator, and this negative electrode, and cathode, anode, and the separator. So here the contacts are there. The positive contact will be here and the negative contact will be here. The negative electrode, separator, positive electrode, positive active material, aluminum current collector, right? So these are the current collectors, which is made up of copper and aluminum. So cathode. Cathode is nothing but the positive terminal. In cathode, we are using the metal oxides which are derived from cobalt, nickel, manganese, iron, or aluminum. Cathode is nothing but it is an positive electrode where we will connect the positive terminal of our controller or our any application we need to use. Negative means anode. Here the carbon-based material is there like graphite. So here we are using graphite, and here the intercalculated layer is been done of the graphite. So what is intercalculated layer? I will show you in the further slides. Electrolyte. Electrolyte, just like the air. What is the air? Air is in a medium. So when I am talking to you, the air is going from the air. The vibrations are going to the mic, right? And from the speaker, the vibrations are coming out, and through the air is nothing but a medium. So that vibrations are going up to your ears. So same like that, electrolyte is a medium, so that the lithium ions and electrons can be transferred from cathode to anode and vice versa, right? So electrolyte is nothing but a medium to transfer the electrons and lithium ions. Separator. What is separator? Separator is an semi-permeable material. It will isolate the electrons and it will just let lithium ions to pass through them. So separator will act as a stopper or act as a dam between them from cathode to anode. So from cathode to anode, just lithium ion will be passed. They will not let the electrons to pass through them. So electron will pass from the external circuit or the whatever the connection we are giving, like load or motor or battery, and headlamps or any kind of other load, right? Current collector. So we are transferring the electrons, we are transferring the lithium ion from cathode to anode, anode to cathode. So we need something to collect that current. We need something to collect that electrons. So here we are using positive current collector and negative current collector. So for positive current collector, aluminum foil is being used, and for the negative current collector, the copper foil is used. Oxidation. In terms of electron transfer, it can be defined as removal of electron from the atom. In other words, the loss of electron from the atom is called as oxidation. So whenever an atom will lose the electron, it is known as oxidation. And vice versa, whenever the atom will gain the electron, it is called as reduction. It sounds like just confusing because reduction means reducing the number of atoms. Someone will thought, but it's different. The reduction means it is gain of electrons, and oxidation means it is loss of electrons. So as we can see in this image, you can see here the metal oxides are there like cobalt, manganese, or iron. And here the intercalculated layer is there. See, you can see this hexagonal shape. It's nothing but intercalculated layer. It is made up of graphite, and the lithium ions are being stored in this intercalculated layer. The lithium ions will lose the electrons. That electrons will be transferred from the external circuit because the separator will not let these electrons to pass through internal circuit. So here the lithium ions will break one electron, and that electron will come from the external circuit. And this lithium ion, you can see the red color, these are the lithium ions. These lithium ions will move from the internal circuit. This electron and this lithium ion will get combined here, and here they will be stored inside the intercalculated layer. Okay, so this is the positive current collector. It will receive the electrons from the external circuit during the discharging of the battery from the negative current collector, right? So it will receive the electrons. You can see the electrons are received by this positive current collector from the negative current collector. This is the cathode. It will store lithium and release lithium ion when the battery is charging. Separator, this will just let the lithium ions to pass through them. It won't let the electrons to pass through them. This is anode. It will store lithium ion and release the lithium ion when the battery is getting discharged. This is electrolyte. It is like a liquid or gel-like substance which will act as a transporter or which will act as a medium to transfer the lithium ions through them. And this is the negative current collector. It will receive the electron from the external circuit during the charging of the battery from the positive current collector. So these are the lithium ions electrons, and this will be the external circuit. I hope you are with me. You are getting the points. Yes. Am I audible?
Yes.
Okay. Working of a battery. So how the battery works, how the oxidation and reduction happens. So we are going to see the redox reaction. The redox reaction. So what happens at cathode? The reduction takes place. Here the cobalt oxide will combine with the lithium ions to form the lithium cobalt oxide. It will form the lithium cobalt oxide, right? LiCoO2. The CO2 plus lithium ion plus electron will form lithiated lithium cobalt oxide. You can see here, right? And the oxidation will take place at anode. At anode, the oxidation will take place. And here the graphite intercalculation, I just told you before, the intercalculated layer. In this intercalculated layer, the molecules or the ions will be inserted or they will get stored, and they will form the lithiated carbon. So you can see this lithiated carbon will be diverse into C6, means graphite plus lithium plus electron. This electron, you can see here, it will be transferred from the external circuit as I have shown you. This lithium ion will get transferred from the internal circuit. So this will be while discharging and this will be while charging. So as we can see here, the positive electrode is cathode and the negative electrode is anode. Cathode and the anode. So as you can see here, in positive lithium ions are moving from anode to cathode. See, this positive lithium ions are moving from anode to cathode. So this is the discharging of battery. So in discharging of battery, we are supplying the electrons from negative terminal to positive terminal. Whenever the current is the electrons are flowing from negative terminal to positive terminal, the discharging of battery will get occurred, right? What is the flow of electrons? Flow of electrons means electricity. So here the electrons are flowing from the electrical external circuit, and the lithium ions are flowing from the internal circuit through the separator. This is the charging, right? So what's happening in charging? Here, positive electrode anode, from the anode, the from at the anode, the lithium ions are getting stored, as we can see from cathode to anode. At the cathode, this metal oxide is releasing the lithium ions, and these electrons are getting stored here at this side, right, at the intercalculated layer. Here the graphite is present, this lithium ion are getting combined with these electrons which are getting from the external circuit, right? So here we are moving the lithium ions to the intercalculated layer so that they will get stored here. Battery characterization. So whenever we store fuel inside our petrol vehicle, we measure it in liters or gallons, right? So how to measure the current which is stored inside the battery pack? So here we are using ampere hour. So unit for battery capacity is ampere hour. How much energy we can store inside that battery pack, or how much electrical capacity does that battery pack is holding inside that. So it is nothing but unit of the battery capacity is ampere hour, Ah. The energy density. Energy density is measured in watt hour per kilogram. So how much energy density we can store inside that per unit kg of that battery pack. So let's say I am having one cell whose 5 milliampere hour, 5000 milliampere hour, and it's of 3 volt, and the weight is 100 grams. So how much energy will get stored inside 1 kg of battery pack? Can anyone tell me? Have you got my question? I am having one cell of 5 ampere hour, right? I am having one cell of 5 ampere hour, and its voltage is 3 volt, and its weight is 100 grams. So how much energy can I store inside the 1 kilogram of battery pack? Are you getting my point?
Sir, once again, repeat the question.
Okay, yes. See, I am having one cell of 5 ampere hour, okay, and 3 volt, and its weight is 100 grams. So how much energy can I store in 1 kg? So see. Yes, anyone?
150.
150. 150.
Sir, 50,000 watts.
50,000 watts. How?
Sir, 1,500 watts, sir. 1,500 watts.
Okay. So see now what we will do. What is watt? Watt is nothing but voltage V into, right? Hello.
Yes.
What is what? V into I. And when we will multiply this V into I with hour, it will be energy, right?
Yes.
Yes. So now what we will do to get the energy, we will multiply this 5 into 3, right? Voltage into current into hour, right? So how much we will get? 150 ampere hour, right? So
15 ampere hour.
yeah, sorry, 15 ampere hour, right? 15 ampere hour. So 100 gram of cell we are getting 15 ampere hour. Now how much I will get in 1 kg? So in 1 kg we are having 1000 grams, right? So we will multiply this with the 10, right? So 150 ampere hour per kg, right? Are you getting my point?
Yes, so it is energy density.
Yeah, it will be energy density of this cell.
पढ़ते रहते हैं भैया पढ़े है कैसे नोट निकाल दो मेरे 3 बार निकालना पड़े इकट्ठे निकाल
Okay, same like that. The power density will be measured in watts per kilogram, right? SOC. So SOC is nothing but the state of charge. This will enable the driver to take the decision about the range of vehicle it can go. Just like our mobile phones. In our mobile phones, we can see the green color battery symbol. By that, we can estimate, we can see how much percent battery is remaining inside our mobile. Same like that, inside the electric vehicles, we are having SOC indicator. With the help of SOC, we can see how much electrical charge or charging has been remained inside our battery pack, and with that charging we can estimate how far we can go or how much range of the vehicle we can get. Are you getting my point? Just like our mobile phones, let's say if I am having 50% of charge inside my mobile phone, I can estimate that it will give me 3 to 4 hours or battery backup, or I can work on that mobile phone or laptop. Let's say laptop. On the laptop, if I am having 70% of charge, I can say that I can conduct 2 webinars or I can conduct 1 webinar. Same like that. Inside the electric vehicle, if I am having 70% of SOC, 80% of SOC, with that SOC, I can estimate that how much kilometer can I travel from that charge which has been remained inside my battery pack. 80 kilometers, 70 kilometers, 100, 110 kilometers, right? State of health. So what is state of health? State of health is nothing but when the battery was new and when we have used the battery pack, so how much health is remaining as compared to when the battery was new, right? So when the battery was new, its health was 100%. And now I have charged and discharged my battery pack, and now its health has been reduced. Now it is giving me less battery backup. So SOH is nothing but state of health. C rate. Charge and discharge rate of battery is governed by C rate. So how much current can we get, or how much ampere hour rating can we get from the battery pack at a single time or at an instantaneous current charge and discharge rate? That is nothing but C rate. How much charge can I put inside a battery pack, or how much charge can I get from a battery pack? So that is called as C rate. Cycle life. Cycle life is nothing but the total number of charge and discharge cycles a cell can sustain before its capacity significantly reduces. Means how much times can I charge and discharge my battery pack is nothing but cycle life. It's just like its life, right? OCV, open circuit voltage. Open circuit voltage is voltage of the battery pack when we are not connecting any kind of load, or when we are not giving any kind of current or supply to that battery pack, like it's not delivering power or it's not receiving power. So when we are getting that voltage, or when we are counting that voltage, it's OCV, thermal runaway. What is thermal runaway? See, just like our firecrackers, right? If I'll burn firecracker, it will let another firecracker to burn. It will let another, right? So thermal runaway is same. It will burn the other cells, or it will burn the cell will burn itself within its active material. Whatever the active material is present inside the battery pack or that cell, they will get burned and they will cause other cells to burn out. Different types of lithium ion chemistries, right? So as you can see in the screen, there are different types of lithium ion chemistry like lithium cobalt oxide. Okay, so here in the anode we are using graphite. As you can see, again at the cathode we are using LiCO2, lithium cobalt oxide. The salt which has been used is lithium hexafluorophosphate, LiPF6, lithium hexafluorophosphate. So this is salt, and the solvent in which it is being in which it gets dissolved is ethylene carbonate, EC. And the anode chemical reaction will be as follows: like lithiated carbon will get diverged into carbon, means C6, and lithium ion plus electrons. Again, this lithium ion, the L plus, will get traveled from the cathode to anode or anode to cathode from the internal circuit, and this electron will get transferred from the external circuit, which will run our load. Again, at the cathode chemical reaction will occur where the COO2, means cobalt oxide, CO2, cobalt oxide, will get combined with this lithium ion and this electron, which will be coming from this LiC6, and it will form lithium cobalt oxide, right? So these are the different types of chemistries. So here, lithium iron phosphate. So lithium iron phosphate is the most used chemistry inside the electric vehicle, as these all chemistries are not used mostly. But here we are using LFP. So we will see about the LFP, as the anode is same inside the most of the battery packs, right? Just in LTO, lithium titanate oxide, we are using anode, titanate as an anode, right? Other things will be remain same. Just the anode will get changed at lithium titanium oxide, and in the LCO, lithium manganese oxide, lithium nickel aluminium, NCA, or lithium nickel manganese cobalt, NMC. In these battery packs, we are going to use graphite as the anode. The other things will be remain same: lithium iron phosphate, lithium hexafluorophosphate as a salt, ethylene carbonate as a solvent. Here, LiC6 will get diverged into L6, means this carbon, graphite, right, into lithium ion plus electrons. These electrons will get transferred from the external circuit, and it will cause the load to get run. FeO4 iron oxide will get combined with lithium plus electron to get form lithium iron phosphate, right? Lithium iron phosphate is getting formed here. The lithium ion is getting combined with this electron, and with this electron, the phosphate is also getting combined, forming the lithium iron phosphate, which is also known as LFP cell, LiFePO4. I hope you are with me. You are getting my points. Hello.
Yes, sir.
So please continue.
Okay. So see, these are the different types of battery chemistry. Here we can see LiCoO2. Here we can see, a second. Here we can see the specific energy capacity, the cost, lifespan, safety, and specific power. Here we will specially concentrate on LFP, lithium iron phosphate, because the lithium iron phosphate is being used mostly inside the electric vehicle. So can you tell me what are the most important factor we should consider when we are trying to build the battery pack for the electric vehicle? Yes, can anyone? Hello.
It should cover more mileage. It should get
Yeah, we need
area
more.
for the
Right. We need more mileage, right? Yes. Any other inputs from apart from this?
Safety.
Safety, right? Exactly, safety. So we, the human beings, are going to travel inside that vehicle. So the most important factor will be of safety, right? Because if anything wrong happens, if the lithium ion cells will get burned out, it will directly cause impact on our safety, on our life, right? So we need something that are more safer. So
The
lithium ion phosphate.
lifespan.
Yes. Yes, even the lifespan. See, we are investing like 15 to 20 lakhs inside our vehicle, like about talking about cars, right? And 1 to 2 lakhs talking about the electric bikes. So we won't replace them after 2 years or 3 years. We need the long lifespan for our battery pack, or even about electric vehicle. So as you, sorry.
at least 5 to 10 years. It should
Right. Yeah. At least 5 to 10 years, it should get sustained. So as we all know, the lithium ions or the battery pack is the most costliest factor inside the electric vehicle. It covers about 50 to 60% of the amount which we are going to pay for the vehicle. Let's say I'm getting vehicle of 10 lakhs. The 50 to 60 percent amount of the battery pack will only go for the battery pack. The battery pack will be like 5 to 6 lakhs if the vehicle is of 10 lakhs. So the battery pack is the most costliest factor inside the electric vehicle, affecting the efficiency, affecting the safety, affecting the cost, affecting the power, affecting the weight of the vehicle. So to consider the lithium ions or the battery pack, it's the most important factor to get considered when we are talking about the electric vehicles. So here we need the high amount of power in the low weight, right? So if we are increasing power, so obviously the weight will also get increased. But if we will increase weight, the efficiency will get reduced. The whole whole vehicle's battery pack weight will get reduced, and it will eventually increase the weight of the car. So here we are considering the cost, specific power, safety, lifespan, and the performance. So LFP is at the lower side in the cost, topmost side in the specific power, the highest safety, as we are going to travel inside that electric vehicle. So we need to consider our safety first. Again, the performance is good, and even the lifespan is very good when we are talking about the LFP cells. So battery pack architecture. What is battery pack architecture? It is nothing but whenever we are going to connect the cells in parallel or series, it will form the module, right? As I have told you, when we are going to connect the series, parallel and series combination of the cells, it will form the battery pack. But inside battery pack, what happens? There are thousands of cells. So we can't connect or we can't group all that cells at the single module. So we need to form the different modules. We need to form the small modules of that battery pack, and then we need to connect them. Again, those modules can be connected in series or parallel to create the battery pack. So let's say I am using 1,000 cells inside the electric four-wheeler. So what I will do, I can't connect the 1,000 of cell at a one time in one unit. So what I will do, I will connect them. I will form the modules. I will connect 100 cells. I will make the modules of 100 cells, another 100, another 100. And again, I will connect them in parallel and series to create my whole battery pack. So again, the advantage of creating module is like the advantage of creating module is like to we can distribute the weight of the battery pack, right? So if I'll connect all the 1,000 cells inside the one unit, it's very hard to remove, it's very hard to maintain, it's very hard to get fitted inside that vehicle, it's very hard to get replaced, right? So what I will do, I will create these small modules so that I can distribute them properly. The weight distribution of the vehicle will get good. Even if there are some fault inside some cells, I will just need to replace that module. I will not need to replace the whole battery pack. I will just replace that module and my vehicle is ready to go, right? So there are different combinations like series combination and parallel combination. So can anyone tell me how the series combination is done and how the parallel combination is done and what happens in them?
A series connection between negative terminal of one cell and the successive of positive one of the successive cell.
All right. And what happens in series? The voltages get increased or current get increased?
The voltage is getting increased.
Right. The voltage is getting increased. And in parallel connection, the current is getting. Yeah. So
parallel current is increased.
Voltage remains same.
Right. In parallel. So now let's say I need to create the battery pack. Now let's say I'm having cell of 5 ampere hour, okay, and of 3 volt, okay. I'm having a cell of 5 ampere hour, and I need to create the battery pack of 48 volt and 30 Ah. So can anyone tell me how should I do this?
A 16 battery in the series and then 16 combination that creates 48 volt. If 3
Right.
volt is lithium ion is there.
Right. So what I will do to get this voltage, right? To get the 48 volt, what I will do, I will connect these cells. I will connect these 16 cells in series, right? 16 cells in series. And so what I will do, like, let's say this is my cell. What I will do, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right? Okay.
Okay.
Okay. So now here I will get 16 volt, right? Sorry, 48 volt. 48 volt. And how to achieve the current rating?
6.
So here,
6 cells
right,
in parallel.
right. So here I will need to connect the 6 cells, 6 strings, right? 6 strings, not 6 cells, 6 strings. So see, this is one string, okay? So what I will do, I will connect right? So what I have done here, 1, 2, 3, 4, 5, 6. Now I have connected this. This is the string of series cell and this is the string of parallel cell. So this is called as one string, right? One string is of 16 cells and I have connected 6 strings to get the 30 ampere hour rating, right? So can you tell me how much cells are there? How much total cells are there?
96.
Right, 96. So now these are the 96 cells, right? So I have created the battery pack of 48 volt and 30 ampere with the help of 96 cells. Now I can't connect this all 96 cells in one module or in one unit because it will get heavy or it is very hard to fit inside the module of my electric vehicles, or it is very hard to place them, or it is very hard for weight distribution. So what I will do, I will make module. I will make the module of like 10 cells, 16 cells, 18 cells, whatsoever, 20 cells, 25 cells. And then again, I will make them in parallel or series connection, and then I will create the battery pack. I hope you are getting my point. Okay, so till here we have seen how to create the battery pack, how are the cells, what are the internal structure of cell, how the things goes inside the cells, how the electron is getting released, how that electron is getting converted into electricity, how the charging and discharging is being done, what is the redox reaction, right? The different types of batteries, chemistry, LFP, the advantages and disadvantages of them. Again, the battery pack architecture, what are the parallel and series combination. Now we are going to focus on the battery failure, right? So you might have heard like lots of rumors or lots of news about the electric vehicles that they are getting burned out, they are catching fire, they are getting they are getting blasted, right? They are very dangerous, but it's nothing like that. Electric vehicles are very safe. Just we need to concentrate on some things which may lead to battery failure, right? So what will lead to battery failure? The uncontrolled charging and discharging, right? Which is nothing but the electrical abuse. So you can see in this mechanical abuse, electrical abuse, and thermal abuse, which will cause the thermal runaway, which will cause the smoke, fire, explosion due to the internal short circuit, anode lithium plating, and cathode oxygen release, right? So see what's happened here. What is mechanical abuse? What is mechanical abuse? So whenever some penetration is there, or whenever I will drop the cell, or in case of crush, or if I am driving the vehicle and if it get crashed to the other vehicle or to the tree, or some accident will happen. So what will happen? It will damage the battery pack. it will crush the battery pack, it will penetrate the battery pack, it will physically abuse that cell, it will mechanically abuse that cell. After the mechanical abuse, what will happen? I have told you about separator, right? So, what is the separator? It lets lithium ion to pass through them. It won't let the electron to pass through them. But if any kind of mechanical abuse is there inside that cell, the separator will get damaged. And if that separator get damaged, what it will happen, that electrons will get flooded from the separator to the cathode, and it will cause the internal short circuit, or it will cause the burnout of that whole battery pack. Right, it will cause very vigorous reaction inside that cell, and it will lead to the smoke, fire, and even the explosion. Electrical abuse. In electrical abuse, what happens? Overcharging and over discharging happens. When the overcharging and overcharging happens, or due to the internal short circuit, what happens? The
Blasting may
lithium
occur.
ion. Sorry.
Blast may occur. It can blast.
Yeah. It can get blast. It can cause fire. It will release the smoke, and even they will reduce. Even if it's not blasting, it will reduce the life of the battery pack. Like, let's say the life of battery is 5 years, but if you are overcharging that battery, or if you are not handling that battery properly, if you are giving very much electrical stress to that battery pack, or you are giving very much thermal stress to that battery pack, the life will get significantly reduced. It will be just like 2 to 3 years, or 3 to 5 years, 3 to 4 years, right? So concentrating on these things are very important. Again, the high ambient temperature and storage temperature. If we are storing the battery pack, or if we are parking our electric vehicle inside the hot summer, or on the like in the open area where lots of sun is coming, again you are charging your battery in the sunny area where the lots of heat is there, and again you are traveling. So what will happen? It will give thermal stress on that battery pack. It will get heated from. It will get internally heated. Again, if you are not properly maintaining your battery pack's ventilation, if you are not refueling, all the thermal coolants, if you are not taking proper care of them, it will give the stress on thermals, right? So they will lead to thermal abuse. And in case of explosion on fire, like if anything wrong happens inside the vehicle, if any other compartment or any other parts caught fire, so it will directly or indirectly give stress on the battery pack, and if the temperature of battery pack will get increased, the reaction will get vigorous, and it will lead to explosion.
Thermal runaway starts when a cell is damaged.
So this is the short video I'm going to show you, right?
Thermal runaway starts when a cell is damaged, causing it to short circuit. It heats up and eventually bursts, releasing toxic and flammable electrolytes and gases. Other nearby cells follow the same process, and eventually they ignite, or in a small number of cases we researched, the gases can explode. When thermal runaway happens, you'll see a dark vapor cloud followed by a lighter vapor cloud. This is not smoke, it's gases escaping from the battery cells. You'll hear popping noises, which are the cells bursting. These have been described as being as loud as gunshots by witnesses. You may hear a whistling or hissing noise, which are the gases escaping under pressure. And when the gases ignite, you'll see highly directional jet-like flames from underneath the vehicle.
Yes, that was all from my side. If there are any questions, you are free to ask. You can ask.
So it was very informative. Can we get these slides you presented here?
Yes, you can connect with our with our team members. They will show.
YouTube. It is available on YouTube. You can.
Sorry,
Okay,
sir.
On
After
YouTube.
this session over, YouTube is available. You can.
We will share the YouTube link on your mail.
Yes.
Thank you.
If anyone having doubts,
very knowledgeable session. Thank you.
thank you, sir. If anyone having doubts, please ask from our expert.
Yes, sir. This side Balaji.
Yes, Balaji.
What happens to the battery pack if voltage gets increased or decreased, as well as current as well?
Yeah. So see, what is current and voltage? Current is we are storing current inside the battery pack. So that battery pack is having some limits. Only up to that limit we can store that current. If you just imagine like dam and river, the dam will let some amount of water. If the flow of the river increases, that dam will get damaged, and if that dam gets opened or that dam get broken down, so the whole there will be flooded, there will be flood, right? So same thing happens inside that cell. So we are storing the current in the form of electrical charges inside that cell, and if the pressure of that current increases, or if we are applying more voltage to that cell, it will cause the separator to break down. It will break the separator, and they will cause the internal short circuit, and they will burn out our cell. Again, it will reduce our battery pack. You have seen in the older eras, in Nokia mobile phones, or in other mobile phones, if we are overnight charging the vehicles, what will happen? The battery pack gets bulged out, right? So in same manner,
Yes.
the lithium ions get damaged if we are giving high voltage or high current to them. So for that, to prevent those things, we need BMS, battery management system.
Okay, sir. Thank you.
Yeah. Any other questions?
Yes, sir.
Yes.
How to properly charge and discharge freshly assembled lithium cell?
Sorry.
So it's to, how to properly charge and discharge freshly assembled lithium cell?
Okay. How to charge and discharge the lithium ion cells properly, right?
Yes, sir. Yes, sir.
See, so here we are using charger. Here there are different types of functionality like CCCV charging functionality, constant voltage and constant current. So whenever we are charging lithium ion cell, there are different types of chargers available for the different types of chemistries. So there we need to connect them properly. We need to see the voltage levels. We need to see the current levels. Again, the battery management system is given so that we can properly charge and discharge the battery pack. So we need to configure them. We need to see the charger is compatible with the chemistry or the type of chemistry. LFP cell is having different voltage, different current levels, different charging and discharging levels. NMC is having different factors. So we need to consider all those things.
Yes, sir.
Yes, any other questions? Hello. Okay. With this, I'll end the session. I hope this session was informative to you and I have cleared all the questions from the audience. Thank you.
Yeah, thank you.
Hello, thanks Shubham for hosting the webinar. And thanks learners for attending the webinar. I hope this webinar helped you out to upskill your learning and skills. I would like to take the opportunities to introduce our company ISIE India products and services that we offer in EV technologies with small video. So just have a patience and go further with the small video. Thank you.
Hello, engineers. Do you also want to expand your knowledge of electric vehicles and want to secure a good job in the automotive industry? Let me help you to get there with our online and offline products. ISI India has been offering specific domain courses as per the industry demands with perks like pay after placement, no cost EMI, placement assurance, globally wide certification by Automotive Skill Development Council ASDC and National Skill Development Corporation NSDC Government of India. We have range of courses in electric vehicle, computer-aided design and engineering, including postgraduate certification and executive PG program in EV, professional master certification program, specialization programs, fundamental programs, and internship in EV, CAD, and CAE. Our postgraduate certification program in EV is specially designed for the students with 120 plus online learning hours, 100 plus hours of industrial projects and internship to give exposure of various computational tools for hybrid electric vehicle applications. It is a 12 months assured placement course with pay after placement, thus encouraging the learning without financial constraints. The course is globally valid, certified from NSDC Government of India. Our executive postgraduate program in EV is specially designed for the working professional who want to upskill themselves or looking for a career change in the EV industry. With 120 plus online learning hours, 20 plus hours of industrial projects. It is a 9-month assured placement course with globally valid certification from NSDC and ASDC Government of India. Our professional master certification program in EV, CAD and CAE is specially designed for the undergraduate students to pave their career path by providing industry relevant skills with 100 plus online learning hours, 5 plus hours of industrial projects. It is a 6-month placement assistance course with globally valid certification from NSDC Government of India. Along with the courses for skilling, reskilling and upskilling, at engineering institutes across India, we are setting up a state-of-art facility, Center of Excellence for e-mobility research and skill-based education, which is equipped with research and project-based learning-oriented experimental setups. This Center of Excellence is not only limited to educate the students, but also it will be utilized for research, innovation and product design and development. It is a combination of 6 labs including EV powertrain training and research lab, battery BMS training and research lab, EV charging and battery swapping lab, software modeling and simulation lab, innovation lab and renewable energy lab. Each lab is consist of number of customized workbenches and machineries. Few of them includes EV drivetrain experimental setup and motor testing workbench, hybrid drivetrain experimental setup with data logger, EV machine cutout section workbench, 2-wheeler, 3-wheeler, 4-wheeler training workbench, battery load capacity testing, battery BMS with CAN protocol workbench, V2G setup, on or off grid work charging station, battery swapping, autonomous vehicle training workbench, solar power generator and software solutions and many more. No matter from which branch you study, we commit to skill and assure you a success in your career. We have spread the joy on thousands of faces, becoming their partner along with the journey towards success. Join us and take advantage to unlock endless career opportunities.
Thanks learners for watching the video patiently. So, any of you want to enroll in the courses, kindly send us inquiry through a QR code displayed on your screen and take the opportunities towards a more sustainable and exciting future. Thank you so much for coming.